Hi, welcome back. This is the third problem in the maximum power transfer examples. And so this one we're doing 8.56. So in this one, we have the voltages given as 20 e to the j0, which is 1. So I'm just going to write 20 for the input source voltage. And as I rewrite this, I need to forgot to erase some of these. So to find the load, I'm going to remove Z load and put VTH at the node terminals of Z load. So as I do that, that gives me a circuit that looks like this. And then I put the terminals for VTH across where I just removed the load. So between here and here is going to be VTH. But I notice on here that this whole branch is floating, which means no current flows through a floating wire. So all the current going through here will be 0. And so I can note here that Vx will actually equal VTH. So now I only have one node and I've got two branches. So this branch and this one. So if I write that, I have Vx minus V over 10 plus Vx over minus 5j equals 0. I can combine the Vx's. And V is just 20, so this is 20 over 10. And I can either keep manipulating this or I can use a simulator. So if I use a simulator just on a simple, what do you call this? So I can even leave it back in the term of just the first equation. And so I'm using x for Vx. And so it's Vx minus 20 over 10 plus x over minus 5j equals 0. And that gives me just a 4 minus 8j. So from this, I just need to convert from Cartesian to polar. And so that gives me a value of minus 1.1. This is in radians. And this one is the radius, which is 8.9. That's the value I need to use for the average power. So before I find the average power, I want to find RTH. So to find RTH, again, remove the load. I remove any independent sources. And in this case, when I remove that independent source, it is a voltage, so it's going to be a short. So V equals 0, looks like a short. And then on this one, I'm going to put my A and B, and I'm trying to find the pathway from A back to B. So if I would like, I can color code the wires and turn that green so it looks better. And then as I take the pathway, I go through R2 and ZL, and then I hit a location where I'm going to split. So I come up through here, and then it's going to split. That split means parallel form. And then it combines again at the green. And so I can say that my ZTH goes through R2 first and ZL. And then now I have two components, that are going to be in parallel to each other. In the first one on the left, it's R1, and then on the right, it's ZC. So rewriting this, I have 5 plus 3J plus 1 over R1, which is 10, and then 1 over ZC, which is a minus 5J. So again, I can use MATLAB and plug those in. And so the equation 5 plus 3J plus 1 over 10 plus 1 over a minus 5J. So I need to make sure all my parentheses are correct. And that gives me 7 minus J for my value. From here, then I want to find the load ZL, which is going to be the complex conjugate of ZTH. And so that yields 7 plus J. That's my answer for ZL. And then my average power is 1 over 8. And then that 8.9 from VTH, which is the magnitude, over RL, which is 7. So it's the real portion of ZL, and then the polar form magnitude of 8.9. And so that gives a value of 1.4 watts. Thank you for watching.